All right, so I'm going to go through a few questions on the review for the quiz on ellipses and circles. And I'm not going to do all the review guide because a lot of the questions are very similar. So at the very basic level, you should know how to graph a circle. So that would be like number 5, when you have it in the form x minus h squared plus y minus k squared equals the radius squared. You should identify that as a circle. So this circle is going to have a center at 1, -2. And the radius is going to be 3, so we just go up 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And all these points on the circumference of the circle that I'm drawing here should all have a distance of 3 from the center. So don't forget that if you were to have a point on a circle, like right here, that you could make a right triangle, and you would be able to know that the radius of the circle would have to match what we have from the equation. So in the equation, that's 3 squared, so the radius is 3. The new type of equation we learned about how to graph was an ellipse. I'll do this in a different color, I guess. Let's do green. So this is an ellipse equation. I pick one that's semi-tricky, and that is this y squared term is not over anything, so I'm going to write it as over 1. And remember that these two numbers are going to be the x radius squared or the y radius squared, or the fancier term we use is this 25 is the semi-major axis squared, and this one is the semi-minor axis squared. And so things you should know are like the center is going to be at -1, -8, so -1 and the -8's way down here. And then because the 25 is bigger than the 1 and it's under the x, that means it's going to be a horizontal ellipse. So 1, 2, 3, 5 to the right. Go away, Java. Perfect timing for an update. 1, 2, 3, 4, 5 to the left. And then the 1 under the y means we're going to have to go up 1 and down 1 and then play connect the dots. And that's our ellipse graph. So you should go through and do the rest of these for practice, but I won't go through them right now. All right, so if we go further in the review guide, let's try that again. We've got some problems here. We have to write the equation. So one thing you have to do for both circles and ellipses is find the center point. And for this one, the center appears to be at 3, -4. Once you know where the center is, the equation is going to be the form x minus 3 squared plus y plus 4 squared. Notice it's the opposites of the coordinates of the center. Ellipse equations always equal 1. Don't forget that. It's a big mistake people make. And then the two numbers that are going to be beneath the x and y term are going to depend on what the semi-major axis and the semi-minor axis is. So for this ellipse, the semi-minor is going to be this shorter radius. The semi-minor is going to be, it looks like a length of 3. And the semi-major appears to be 1, 2, 3, 4, a length of 4. So the denominators are going to be the squares of those radii, and that's your equation. Circle is the same idea. The center is at, it looks like -3, -2. And because it's a circle, the radius is a constant, 1, 2, 3, 4. It looks like to be a distance of 4 in this picture. So the equation would simply be x plus 3 squared plus y plus 2 squared equals 16. Yeah, it won't fit on there. So for the circle equation, you don't have to write the numbers in beneath each of these terms. You would just write the equals on the right side. So let's see if I can zoom on down a little bit. So that was some of those questions. Oops, too far. I always have a hard time using this. I don't know why. I think this would be easier to, there we go. Almost there. I think a little bit further. Oh, further. Okay. Yep, that's what I did. So let's do a couple of these complete the square type problems. So the idea is, and let me actually do 4 first because 4 is the easier kind. So if you look at 4, you'll notice that we have an x squared and a y squared term, and the numbers in front of them are the same. Anytime you see that, you can conclude right away, based on what we know of different shapes, is that it's going to be a circle. We will amend that rule a little bit later, but for right now, we've got x squared and y squared. And anytime that's been happening, that's been giving us a circle if the number in front of them is the same, and it is because it's both a 1 here and a 1 there. If the numbers are different, that's when we're going to get an ellipse, and you'll see why in just a minute. So there's a couple steps you're going to do to write this in what's called standard form that will enable us to find where the foci are and to make the graph. The first step is always to group all the x terms together, which you'll notice in this problem there aren't any x terms besides the x squared. Then you're going to group together all the y squared terms. So we have a y squared plus an 8y, because we combine these two like terms. Then on the right side, we're going to go ahead and subtract the 1 so that we have all the constants on the right side. Now we're going to go through a process of, let's call it completing the square. And what you do in that is you take your binomials. So here I've got a y squared plus 8y. We're going to think of a number that we can add here. So this will become something called a perfect square trinomial. And the rule we developed, and make sense of this in a minute, is if you take half of the middle term, which is 8, divided by 2, and then square it, you will get the magic number we want to add. So in this case, that's 4 squared, which is 16. So I claim that we need to add 16 on the left side, which means we also have to add 16 to the right side because we need to make the equation balanced. So you'll notice that I'm not going to do this for the x squared term because it's already a perfect square. If there's not like a plus 4x or something else here, you're just going to leave it alone. So now what we have is x squared plus, and the y squared plus 8y plus 16 term actually factors really nicely into y plus 4, the quantity squared. And the reason why is if you did y plus 4 times y plus 4, and you FOILed it out, you would get a y squared, a 4y and a 4y, which is our 8y, and then 4 times 4 is 16. So this number here is always half of this number, the 8, and it's the square root of this number, the 16. That's why we picked 16. It was so that it would make this factoring process easier. And then you'll notice the right side will be 15. We now have enough information for identifying information about the circle. So like we should be able to say that the center is at 0, -4. We should be able to say the radius is the square root of 15. Now you notice it says it has this question about the foci, and we didn't really talk about this in class, but it turns out for an ellipse, the foci are these 2 points here, roughly, that help define how big it is, because we had this string, and you'd have a center in the middle. If you were to make the foci come closer and closer together so that they go on top of this center point, what you end up is with a circle. So for this, technically, and I won't ask you this on the quiz, so don't worry about it too much, but just something for you to think about. Imagine if those foci came together, they would actually land on the center point, and so the foci would just be the center at 0, -4. So we don't usually talk about the foci of a circle because it's just the center, but it does technically exist. What I more want to talk about is a problem like number 1. So number 1, we're going to do the same process that we did for a circle, but this time we need to be a little bit more careful. And I'm going to see if I can zoom in a little bit. Here we go. So what I mean by being careful is we have numbers in front of the x squared and the y squared term, so we're going to have to watch out for that. We're going to group together the x's like we did before, and we'll group together the y's like we did before. And I'm going to move that 131 to the other side by doing the addition property. Add 131 to both sides. The mistake a lot of people make here is they go right to completing the square. And completing the square only works well if you have the leading coefficient of the square terms factored out. So I'm going to do that right here. In front of the x squared is a 4. So I'm going to divide out the 4 from both of those terms to write it with only a 1 in front of the x squared. Now do the same thing with the y terms, pull out the 9. And you'll notice I'm leaving a space there, and that's because now we're going to add a number that's going to complete the square. Half of 2 is 1, and if you square that, you get 1. Half of 2 is 1, and square that, once again, we add 1. Now here's the next place where people make mistakes all the time. Here I've added the number 1, and you're remembering that you need to add that number to the other side to balance it out, but be careful, you've actually added 4 ones. So over here, you need to add 4 ones. Likewise, we added 9 ones here, so here I need to add 9. Now we go through and factor this, so this would be 4 times x plus 1, the quantity squared, plus 9 times y plus 1, the quantity squared, equals 131 plus 9 is 140, plus 4 is 144. Now, this is what the standard form of an ellipse looks like, and that's not quite there. So what we now need to do is divide both sides by the number on the right, because that'll make the right side equal to 1. And now we have to deal with 4 over 144. This is a fraction we need to reduce down. The easiest way to do this, and hopefully this will make sense, if you were to take 144 and divide it by 4, that will give you the number 36. So if you did 4 divided by 144, that'll give you a 1 with a 36 on the bottom. So on your calculator, if you just divide them upside down, it's going to give you the number on the denominator. So here's what we have now. X plus 1 squared over 36 plus, and if you do 144 divided by 9, you will get 16. So now we have the equation of our ellipse. And it's definitely an ellipse for 2 reasons. One, these two numbers were different, the coefficients of the square terms. Or at the end, you'll notice that the numbers on the bottom are different. Now let's talk about, so there's lots of things you can write here. So for the reason, you could say that the coefficients of x squared, and y squared are different. Or you could say like the two radiuses are different, or however you want to word it. All right, so now for the foci. So I'm going to sketch this a little bit, although you generally don't have to make the full sketch. Some of you can do a lot of these problems without drawing out as much as I'm going to do right now. So we know that the center is going to be about at -1, -1. So -1, -1 is like, oh, I don't know there. And then this is a horizontal ellipse, so we know that because the semi-major axis is going to be the larger number, and that larger number, semi-major axis squared, I should say, is a larger number, and that's the number beneath the x. So this number beneath the x here tells us that the x radius, or the semi-major axis, is going to be 6. So we're going to have a vertex here and a vertex here. This number 16 under the y tells us we'd have to go up 4 and down 4. So it's going to look something like this, roughly. And I'll just say here that distance is 6, and this distance here is 4. Okay, so now what we need to do is we need to know that there is this property in an ellipse. And that property is that the foci are always going to be somewhere on the semi-major axis. There's a right triangle that we can create that connects the semi-minor axis with the foci, and then this hypotenuse that is, I wish I picked a different color, that is right about here. And the values we can see from the picture are not so hard. One of them is clearly going to be 4. We know that one of them is going to be f, the focal length, which we don't know. And then we also need to know this other number here. And it turns out that the semi-major axis is always the hypotenuse. So we get this Pythagorean property that f squared plus 4 squared has to equal 6 squared. If you go through and do the Pythagorean theorem here, you're going to get f is, I believe, the square root of 20. And my video is about to run out, so I'm going to have to make one more video to finish up.